In this video, still under electrolysis, I'm going to handle electrolysis of aqueous copper to sulfate solution. And understanding electrolysis of aqueous copper to sulfate solution, the basic thing that we need to start with is formation of aqueous copper to sulfate solution. Now, to understand that, the first thing you need to know the composition and properties of copper to sulfate. Now, copper to sulfate or the copper sulfate solution is made up of copper ions and sulfate ions. I discussed sulfate ions as a radical reacting with the copper metal to give us the copper to sulfate solution. Now, the only thing that we need to know, the major characteristic of copper ion is that they're always blue in color. So meaning when I'm having this, I'm going to form copper sulfate. But when hydrated, this one is always white when it is anhydrous, meaning it has no water crystallization. But when hydrated, it will have some molecules of water, which X can be a number, 2, 3, 4, etc. when hydrated. So meaning I can decide to have copper to sulfate 0.5 moles of water. This is hydrated salt. Hydrated salt, it has water of crystallization. Water of crystallization. So whether I'm having hydrated or anhydrous form of copper sulfate, it doesn't matter. The key thing is I can start with anhydrous copper sulfate or hydrated copper sulfate salt. Then I decide to dissolve it in water to form an aqueous form of it. So I'm simply going to have my beaker. In my beaker, I'm going to have water. And into it, I'm going to add copper sulfate salt, whether hydrated or anhydrous. The key thing you have to know that anhydrous form is white, hydrated form is always blue. Now, when I do this, at the end of the day, I'm going to have a beaker, and my beaker is now going to have a blue solution of copper sulfate X water. And I've told you what the X symbolizes. So I'm having my copper sulfate solution, which I'm supposed to subject to electrolysis. Now, when I decide to subject that to electrolysis, it's going to be very simple. I must have my electrolytic tank. I'm going to draw my electrolytic tank. And my electrodes. I need a wire, a switch, source of power or electric current. I need a bulb to denote that electricity is flowing. Then, sorry, let me draw it in a better way. Yeah, that's better. Now I need to ensure that I have copper to sulphate solution. As my copper to sulphate solution. Now, the next analysis that I'm still doing to my electrolytic tank and its system, I need to know that this is my cathode, this is my anode, then that's the electrolytic tank, this is my switch, this is my bulb, and source of power is here. Now, the next analysis that you need to know are the ions present. And the ions present, because we are dealing with a solution, so I also have water. So I'm going to have copper ions. I'm also going to have sulfate ions because of water, hydrogen ions, and also hydroxide ions. All these are ions present in the electrolyte. So the first thing we need to know is the reaction at the anode, because it is at the anode that electrons are donated. So the first thing is reaction at the anode. It is also known as oxidation reaction. So you can even call it oxidation. Oxidation reaction. So the first thing that happens is when electric current flows in the system, because the anode is positively charged, I'm going to have sulfate ions and hydroxide ions moving. Sulfate ions and hydroxide ions moving to the anode. So when these two moves to the anode, what do you think is going to happen? I'm having sulfate ions and also hydroxide ions moving to the anode. What do you think is really going to happen? Now, the key thing that you need to know is based on preferences. Based on preferences. Now, the key thing that every student needs to understand is that when such reactions occur, all these substances are going to move to the anode. And sulfate ions are almost impossible to oxidize because they are stable. But hydroxide ions can be oxidized. So the only option that is remaining is the oxidation of hydroxide ions at the anode. So it is the hydroxide ions that are going to be oxidized to give us electrons that are going to be picked at the cathode. So when electric current flows in the system, sulfate ions and hydroxide ions will move to the anode, and based on preferences and stability, hydroxide ions will be oxidized to give us OH, to give us a reaction like this. Hydroxide ions must give us an electron, and it is going to give us an electron when it forms oxygen and water molecule. It's going to give us oxygen plus electrons. So I need to know that for the formation of, because I need to balance this. So when I want to balance this thing, I'll simply put a 4 here. I'm going to put nothing, oxygen. I'm going to put a 2 here. So how is that going to balance? For each hydroxide, there's 1 electron. I'm going to put a 4 here. So that's the explanation of what is happening at the anode. So at the anode, we are forming oxygen gas, water molecule, and 2 electrons are donated. At the cathode, there's a reduction. And we said that cathode is negatively charged. For that matter, what will happen? Only copper ions and hydrogen ions will move. Only copper ions and hydroxide and hydrogen ions will move. And when that happens, we really need to know which one will be reduced. And if you check very well your reactivity series table, you'll come to realize that hydrogen is above copper in the reactivity series. So the electron cannot be added to hydrogen, but instead it will be added to copper, because copper is the least reactive. Now, for that matter, hydrogen will not be reduced, but copper will. So I'm going to have a situation where copper must accept the 4 electrons that were donated to give us copper solid. And how do I balance that? Because this is aqueous, I put a 2 here, then a 2 here, sorry, a 2 there. It's going to justify the 4 electrons that were donated at the anode during the oxidation reaction. Now, what remained in the solution is hydrogen at the cathode. What remained in the solution is sulfate. at the anode. Now, what are the observations? What are the observations that will be made? Remember, I told you that each and every stage you need to justify an observation that will be made. Now, observations that will be made during the reaction are as follows. The first observation is production of oxygen. At the anode, you realize that we produced oxygen and water. We produced oxygen and water. Water is colorless liquid. Oxygen is also colorless gas and odorless. But we can justify its production through observation of bubbles at the anode electrode. So what are we going to say? An explanation to justify that we say bubbles of a colorless gas. But what are the properties of this colorless gas? How will you justify? Remember, hydrogen was colorless, nitrogen is colorless, oxygen is colorless, carbon dioxide is colorless. There are several gases which are colorless. So what will be the justification that the specific gas produced at the anode is purely oxygen? So we say bubbles of a colorless gas which relights a glowing splint. A glowing splint is observed, stroke produced. That's the test for oxygen gas. Bubbles of a colorless gas which relights or rekindles a glowing splint is observed at the anode. The next thing is the cathode observation. We said at the cathode we are forming copper solid. And what are the properties of copper solid? Copper is a brown gas, a brown solid, sorry, brown solid. Copper is brown in color, and in most situations we are going to observe a brown lump of solid that is deposited below the cathode electrode. So copper is always brown, or some people can go ahead and say it is orange red in color. A mixture of orange and red will give you a brownish color. So whether it is orange red or brown, it doesn't matter. The key thing is you know the color. It is always brown in color. So we are going to have brown deposits of copper below cathode electrode. So when you go back to your electrolytic tank, you'll realize that on your electrolytic tank, you are going to have some deposits of copper here because we had copper ions. This is where we are going to form our copper then bubbles of oxygen will be leaving. They pop around. Yeah. So that's what is really going to happen during electrolysis of copper to sulfate solution. The next thing that is always justified under observation, the next thing that is always justified under observation is the state or the pH of the whole system now. What happened was sulfate ions remained in the solution and also hydrogen ions. When the switch is opened, meaning the electricity is cut off from the system, these two ions will react to give me H2SO4, which is acidic. So initially, this is an acidic solution which can be justified using any acid test, acidic test. You can even use litmus paper. You can use litmus paper. Now, when you use litmus paper, you know the changes that will happen. Now, it is now becoming acidic, but it started when it was more of a neutral solution. It is now acidic. Now, any acidic solution will give you a pH of below 6. Below 6 based on its concentration, because 7 is neutral. The next thing that I want to justify is based on color of the solution. Color of the solution before and after electrolysis. When we started the reaction, copper sulfate solution was blue. In fact, deep blue. But as the reaction proceeds, the deep color fades until at the end it becomes colorless. Why? Copper ions, copper 2 ions that are responsible for the blue color, are being reduced slowly by slowly to form copper solid, which is a metal. So copper ions keeps on being reduced to form copper metal. And remember, they're the one responsible for the color characteristic. That was calling, well, that's what's causing the solution to change color from blue, because this one are blue in color, to colorless. Because at the end of the day, after all the copper ions have been reduced, we want to remain with the hydrogen ions in solution and sulfate ions in solution. When the two joins, we form H2SO4, which is colorless. Thank you very much, and I've given you justification of everything that is happening as far as electrolysis of aqueous copper sulfate solution is concerned. Have a wonderful time, and let us meet in the next video.